Hey, welcome back. We're in example 2 where we're going to use sine, cosine, and tangent to find the missing side of a triangle. So looking at problem A, we see that the angle theta is 35 degrees. We know the side opposite of the angle theta is 7. And we're looking for the hypotenuse, which is x. And in the acronym SOHCAHTOA, sine is the ratio of opposite over hypotenuse. So we can say that the sine of the angle, which is 35 degrees, that is equal to 7 over x. That's the ratio of the opposite over the hypotenuse. Then we can cross multiply, so we'll have x times the sine of 35 degrees, and that's equal to 7 times 1, which is 7. And then to get the x by itself, we're going to divide both sides by the sine of 35 degrees. So x is exactly equal to 7 divided by the sine of 35 degrees. And in the calculator, to evaluate that expression, we want to first make sure that we're in degree mode. And remember, the default for the calculator is radian mode. So we need to hit the mode button, arrow down to radians, sideways to degrees, and press enter so degree mode is enabled. Then second mode gets us back to the home screen, and we're going to evaluate 7 divided by the sine of 35. And since we're in degree mode, we don't need to put the degree symbol, and we'll press enter. And we're going to round our answers to 4 decimal places. So we look at the 5th decimal place, which is a 2. That tells me to keep the 1 because we're rounding down. So 12.2041 would be rounded to 4 decimal places. Okay. In example B, we have our angle theta, which is 14 degrees. We know the hypotenuse, which is 8. And we're looking for the side adjacent to the angle, which is x. And in our acronym SOHCAHTOA, the cosine is the ratio of the adjacent over the hypotenuse. So we'll write out our equation. Cosine of 14 degrees is equal to the ratio of x, that's the adjacent side, divided by the hypotenuse, which is 8. Then when we cross multiply, 8 times the cosine of 14 degrees is equal to x. And we're going to evaluate that in the calculator in degree mode. So 8 cosine of 14. Since I'm in degree mode, I don't need the degree symbol. And I press enter and round to 4 decimal places. So the length of that adjacent side is approximately 7.7624, right? I'm rounding that 3 up to a 4 because the 5th decimal place is a 6. Okay, so go ahead and pause the video and try example C on your own. You want to find the length of x, given the opposite side is 30 and the angle is 47 degrees. And then when you're ready, you can resume the video and we'll go over it together. Okay, so 47 degrees, the opposite side is 30, and we're looking for the adjacent side. So the TOA in our acronym is tangent is the ratio of opposite over adjacent. And so when we look at that ratio, tangent of 47 is equal to 30 over x. We're going to multiply both sides by x, and we have x times the tangent of 47 equals 30. Then we divide both sides by the tangent of 47, and 30 over tangent of 47 in degree mode, that's 27.9755. Because the fifth place is a 5, we round the 4 up. Okay, so Mr. Math tried to find the values of x and y in this sketch, rounded to 2 decimal places, and his work is shown below. I'd like you to pause the video, analyze the work, and see if you can find what error Mr. Math made, because the side y is not approximately 31.83. So go ahead and try that on your own, and when you're ready to go over it, resume the video. Okay, so the error that Mr. Math made is when he evaluated 31.7 divided by the tangent of 86. Okay, that answer was 2.2167 had we rounded to 4 decimal places. Because he only rounded to 2 decimal places, he created a pretty significant round-off error in his answer. So he should have gotten 31.78 as his answer to approximate to the final answer to 2 decimal places. But because he rounded on the way, he created round-off error in his answer. So you want to make sure that when you have to use a decimal approximation and carry that into another part of the problem, maintain at least 4 decimal places of accuracy, or use a value that is exact. So instead of using the cosine ratio to find side y, he could have used the sine ratio instead and been able to use exact values. 31.7 over sine of 86 would have gotten him that 31.78. That would have been a better approximation than what he had with the round-off error of 31.83. So with that lesson learned, go ahead and try this problem on your own, where you're given the length of a side and the angle 55 degrees in a right triangle, and you want to find the remaining 2 sides, x and y. So go ahead and pause the video, try that on your own, and when you're ready to resume, you can restart. Okay, so to find x, we use the tangent ratio. Tangent of 55 degrees is equal to x over 4. That's the opposite over the adjacent. So x is exactly 4 tangent of 55. Then in degree mode, we get approximately 5.7126 rounded to 4 decimal places of accuracy. Okay, then keeping the exact value in mind so that I don't have to use my decimal approximation, I chose the cosine ratio to find y. If you use the sine ratio instead, that's okay. Just make sure that you use at least 4 decimal places of accuracy with your opposite side. Okay, then y is exactly equal to 4 divided by the cosine of 55 degrees, which is approximately 6.9738.